Hi science students, this is Ms. Wilson and today we're going to focus on graphing relationships of volume, pressure, and temperature in gases. As a quick reminder, we've talked about three different gas laws. As volume is decreased in a container, I know the pressure is going to increase. There's less room for those molecules to move around. My second reminder to you is going to be that as I increase the temperature, I am increasing the volume. Those molecules are going to start moving faster, and the gas particles are going to hit the container more often with greater force. So the volume of the gas will increase. Lastly, my temperature is increasing, so my pressure is also going to be increasing. As those particles are moving faster, the amount of collisions that occur are going to increase due to that higher energy level of the moving of the molecules. What we're going to do together right now is practice with a popsicle stick, looking at those three variables: pressure, temperature, and volume. We want to focus on the relationship that those three variables have with each other, and as I change one, what occurs with the other two variables. For each of these examples, we're going to keep one variable constant and look at the other two variables in reaction to one another. So for our first example, we're going to need a popsicle stick. So what you're going to do is you can either use a popsicle stick if you have one at home, but if not, you can use an index card, you can use a piece of paper. It just really needs to be the shape of a popsicle stick. If you need to pause the video to go find some material to use, please do that. I've got my popsicle stick here, and on my popsicle stick, I've written my three variables. I've put P for pressure, I've put T for temperature, and I've put V for volume. They need to be in this order in order for you to use it easily. If you need to pause the video to make your popsicle stick, please do that. Let's go ahead and move forward with our first example. You're going to find this on your worksheet. It's going to be in the very top of your sheet. And the first example is going to be that you decide to make a balloon animal. As the balloon is being twisted, it increases the pressure inside of the balloon. What happens to the volume? So I know that in this scenario, the temperature is not changing. It doesn't say anything about that in the word problem. So I'm going to put my finger over temperature, and you can either follow along with my finger in the bottom right hand of the screen, or you can click along as we show you the larger model. So you're going to place your finger over T because temperature is constant. And it says that the balloon is being twisted, so the pressure is increasing. Anytime it says that it's increasing, I want to move that variable up. So it's increasing, I'm going to move up my P, my pressure. As it moves up, I'm going to notice that the volume is decreasing. The volume is moving down. So I know in this scenario with the balloon animal that it's decreasing. As my pressure increases, my volume decreases. Let's go into our next example. The second example says, on a cold winter day, you go to the store to buy balloons for your best friend. When you leave the store, what happens to the volume of the balloons? So it's asking me about volume as a variable. It's telling me that the temperature is different inside the store and outside the store. So I'm going to assume that the pressure inside the balloons is what's being held constant. So I'm going to put my finger over P, over pressure. And it says that as I leave the store, it's going to be colder outside than inside. So I know I'm going to move my temperature down to show a decrease in temperature. When I do that, I can see that the volume also decreases. So as I move the temperature down, the volume moves down as well. So in this scenario, the volume is going to be decreasing. As temperature decreases, volume decreases. Let's do another example together. We have a can of soda, and we're going to shake up the soda and then open it. As I open it, I'm decreasing the pressure. So what's happening to the volume of the carbon dioxide in the soda? So I know that I'm changing the pressure, and I know that I'm asking about the volume. So those two variables are the ones that are not constant. So I can assume that temperature is constant, and I can put my finger over that. It says that I've decreased the pressure as I open the can. So I'm going to move the P down. As I do this, I can see that the volume is increasing. It's moving up. So for this first example with my soda, I am increasing the volume. You are going to go on and continue with the questions that are on your sheet. Make sure that you've identified each example as an increase or a decrease, either in pressure, temperature, or volume, depending on the scenario. We're going to go ahead and move forward. If you need to pause the video here so that you can complete the worksheet, please do that. Let's go ahead and do some practice with some graphing. So we're going to look at one example together, and this example is going to be looking at the relationship between volume and pressure. So we're going to look at this math connections example together, and then I'm going to give you the sheet in order for you to complete the next two examples on your own. So if you need to pause the video or rewind the video at any point, please do that. So this scenario says that the table below shows the relationship between the volume of a gas in a container being passed down by a changing pressure. The temperature and mass of the gas are held constant. So I can see that my temperature is constant. And on my stick, if my temperature is constant, if I increase the pressure, I should expect that I'm going to have a decrease in volume. Or if I decrease the pressure, I should expect that I'm going to have an increase in volume. So when I look at my data table first, before I start graphing, I see that my highest number of volume, I have 5 cubic meters, has the lowest amount of pressure. And that does line up with what we just did with the popsicle stick. If I look at my lowest cubic meter volume, 1 cubic meter, I'm going to notice that I have the largest number for pressure for this one. So this does line up. So I'm going to go ahead and graph that relationship between the volume and the pressure in this container. So what I need to start with first is I need to label my increments on both my x and my y axis. So for volume, I'm going to put 1, 2, 3, 4, 5, 6. For pressure, I'm going to go in increments of 5. So 5, 10, 15, 20, 25, 30, 35, 40. As you're choosing your increments for your graph, that can be a little difficult for students to decide what increment should I use, 2s, 5s, 10s. You want to look at whatever your largest number is, and you want to make sure that whatever increment you choose, that last little line is just a couple numbers above this. I don't want to label this with 10s and I have all the way up to 100 if all I need to graph is up to 40. So I just want to make sure that the increments I'm choosing make the most sense and that all of my numbers will fit, but I won't have a lot of extra room on the top or the bottom. So let's start with our first row here in our table. I see 5 cubic meters. I see 7.5 for my pressure. So I want to jump over to 5 cubic meters on my graph. When I do this, I'm going to be on this line here, and I'm going to go up to 7.5. So I'm going to be right here. I'm then going to go to 4 cubic meters. That's the next row on my graph. And it says I have a pressure of 9.375. So I'm going to put 4, and I'm going to go up to 9.375. Number 3 cubic meters. I'm going to be on 12, so I need to jump over to 3. I'm going to go up to 12.5. 2 cubic meters. I'm going to go up to 18.75. And number 1 cubic meters, I'm going to go all the way up to 37.5. What I'm noticing is that for my highest number of volume, it's my lowest number of pressure, and vice versa. For my lowest number of volume, it's my highest number of pressure. So I have a feeling that that is important here. I'm going to go ahead and connect my lines here. I'm going to notice that this really is not a straight line. right? This is not very linear. And in math, you've talked about this. We've also talked about this in science. But just as a reminder, in case that we need some refreshing on graphing, I'm going to grab another piece of paper. So on this piece of paper, I'm going to remind you of a couple things. If you want to write this on a sheet of paper, please feel free to do that. So I'm going to want to first remind myself, what's the difference between a linear graph and an exponential graph? I know that a linear graph means that something is happening constant and that both numbers are increasing constantly. Linear is going to be a straight line. Exponential, I know that there's going to be an increase or a decrease being represented. However, it's not happening at a constant rate. So my exponential graph is going to look more like a curve. It might be increasing rapidly and then slowing down, or the opposite. If I'm looking at my graphs, though, I know that the direction it's going also matters. So if my line graph is going upward to the right, I know that's going to be showing a positive interaction. And I know that if my graph is going down towards the right, this is showing a negative slope of some kind. So just as a reminder, we want to remember that linear graphs look straight and exponentials look curved. We want to remember that positive is moving up towards the right and negative exponentials are moving down towards the right. These are my positive slopes and my negative slopes. Just as a reminder. So let's get back to our graph. So we're looking at this one. This is the one we've graphed so far together. I can see that it's going down towards the right, so I know that that's going to be a negative slope. I can see that it's not a straight line, so I know this isn't going to be linear. So it says, what is the shape of the graph? So for this one, I know that it's a negative slope. And that it's not a linear graph, it's an exponential graph. It says, is it proportional? And yes, it is. I know that it's inversely proportional. My last question said, what is the relationship between the volume and the pressure of the gas in the container? So when I looked at my table, I noticed that my volume, as it increases, my pressure decreases. Or vice versa. As my pressure increases, my volume decreases. So I know that the amount of space certainly has a relationship with how much pressure, how many collisions of those molecules are occurring. So this says, what is the relationship between the volume and the pressure of the gas? So I know that it's going to be an inverse because if one goes up, the other goes down. So I'm going to first write that. This is an inverse relationship. But then also, I'm going to write as volume decreases, pressure increases. And so when you go on to do your 2 questions that you have that are like this, I want you to be thinking the same thing. Is it positive slope? Is it negative slope? Is it linear? Is it exponential? What is the relationship that they have? If I see an increase in volume, I should see a decrease in pressure. Or if I see an increase in temperature, I should see an increase in volume. Those same relationships that I went over at the beginning of this video should be what you are experiencing as you're graphing and looking at this data. If you need to go back and watch the beginning of the video to remind yourself of those relationships, please do that. You are going to go on and you're going to look at questions 6 through 11 on your Math Connections sheet. You should be able to type directly into the document and submit it. If you would feel more comfortable drawing your graphs on paper, rather than creating them on that Word document, you can. If you feel comfortable enough to add shapes